So I can just move that down. Okay, so here's the Etherpad URL that it'd be great if you could all visit and sign in. We just like to know who's coming to the workshops in case we ever need to ask some departments for some funding or something. And if you haven't downloaded the data on line 15, you can download the data from the Etherpad. Please save it on your desktop. And then I forgot to include one data file. So on line 47, if you could copy the text from 47 to 57 and save it in a text file on your desktop called haiku.txt. We're just going to play with that for a little bit as a simple example. Oh, and let me get the URL for you guys back up there. There you go.
You can probably borrow, the nice little character. Yeah, probably might go good if they use that pieces from that.
And if you haven't used the Etherpads before, over here on the right-hand side, if you're unnamed at the top, instead of seeing your name up here, just fill in your name. And you can pick a different color. If I'm not feeling purple today, I could be pink. While we're waiting, I'll kick off at 3:30, but I wanted to mention the upcoming event. So next session, we're going to have our first co-working session. So the idea behind these is that there won't be a session leader. We can all just come hang out here, bring our own work on our laptops, and work away on your own projects and ask each other questions. If there's something you've been struggling for a while with, or you've noticed that somebody here you've been chatting with, they have a little bit of expertise in an area you want to know more about, feel free to chat with them about it. So I think that could be really exciting, and well, at least I'm extremely excited for it. And then the second thing that we're going to do on Friday, August 21st, is we're going to have a hacky hour here at SFU. So we're all going to go to Club Ilia at 4:30 on Friday, and we're just going to hang out, socialize, get to know each other a little bit better. Feel free to bring your laptops. Again, it can be a bit of a co-working session as well, just to get to know each other a little bit more, and hopefully break down some of the barriers that prevent us from helping each other out or collaborating. I'll just write the URL down on the whiteboard too.
I know that there's an XKC script for this. I don't know offhand how to unparse something. XZF. Yeah, it's GZF. Or I'm just trying to get the.
You go with XZF to XZF. I don't know.
Is someone having trouble getting the data?
Yeah. So
If it's BC, it's J. And if it's BC, it's J. And the new versions of Python, you need to run it automatically detect. Yeah. I just want to unzip whatever this, this file is, because I'm doing it as it's.
Oh, okay.
iPad, so I just SSH my.
Gotcha.
Thing.
There's an unzipped version of it on GitHub.
Oh, that would probably work.
Yeah, so if you go to the repo, maybe Bruno, you can take him there.
If you go to the repo, you can probably get the link. That would probably be easier. Oh, this is a reference.
All right. So just for the few people who just arrived, On the Etherpad, if you haven't downloaded the data, on line 15 is a link to grab the data. I forgot to include one file. So at the bottom of the Etherpad, you can see there's a little poem. So if you could save that poem as haiku.txt on your desktop, we'll be playing with that. And save the data on your desktop as well. And we still have a couple unnamed on the Etherpad. So if you're unnamed, just at the top where it says, for me, it says Tiffany Timbers, you would see unnamed there. Just fill your name in. All right. So yeah, so we're just going to kick off now because it's 3:30. And so what I'm going to be talking to you guys a bit about today is how to use the Unix shell to do a little bit more slightly advanced features, or we can say intermediate features. So we're going to learn how to use the tool Grep, which is a program that will let you basically, in the simplest terms, just extract rows that match a pattern that you're interested in. We're also going to learn how to use awk, which we can use from the command line. And awk can do a lot of things, but all I'm going to show you is just kind of getting into awk, using it to grab some columns. So those are things we'd like to do with data sets pretty quickly and easily from the shell. And then the last thing I'm going to talk to you about is using a third tool called find. And find you can use to grab a whole bunch of files that are stored in different places on your computer if you, say, wanted to concatenate a whole bunch of files together. I like using these shell tools as opposed to the programming languages that I'm most familiar with, MATLAB and R. And when I start to use bigger data files in MATLAB and R, sometimes I find, well, at least in R, I often have to load the entire thing into memory, and that can be really slow. So if I just need to grab a few pieces, or if I want to make my file smaller and then load it into R, for example, is why I use these tools. So I'm just going to make the Etherpad small. You guys, if anyone forgets where it is, the URL is up here on the whiteboard. And I'm going to get all of us to, I need to make that file too. So just make sure that we have that haiku.txt file made. Okay, to go back to the Etherpad. Hello, yeah, please take a seat. So I'm just opening a plain text editor. So you'll need a plain text editor as well today. So you don't want to be using Word, something like Notepad or Text Wrangler or Sublime. And just going to save this poem as haiku.txt on my desktop. And I already have the data saved on the desktop. And I will do that. So as I mentioned, we're going to be working in the shell. So if we can all open our shells, so on the Mac or a Linux, that's going to be terminal. If you haven't opened that before, that's going to be in your utilities folder of applications. And on a PC, you're going to probably be using git bash. Oops. So I'm just going to make the text bigger. Is that big enough for everybody to see? Yeah, we're good. Okay. And the other thing is that we're going to be using stickies to communicate today. So I know everyone is on board with me. So we'll keep the yellow sticky as a happy sticky and the red sticky as an unhappy sticky. So if I'm going too fast, put up a red sticky. And the first thing I'd like to know, I'd like us all to do is to open up our bash shell and navigate to the desktop. So with the bash shell, to find out where we are, we can type pwd for print working directory. And it tells us that I'll be in T-Timbers, you'll likely be in your home directory. And then we can use the ls or list command to see basically what is contained within that directory. Yeah, Bruno?
You want to print out a cheat sheet?
Sure. I didn't make a cheat sheet.
No, just get one online.
Sure. Yeah, that'd be great. So we can see that one of the directories that is right basically in our directory is desktop. So we can just use the cd command, so change directory to desktop. So we just type cd desktop. And then if we type print working directory again, you all should see desktop here. So give me a yellow sticky if you are all there. Just want to make sure. Perfect. Okay, this looks awesome. Pretty much everyone's there. Cool. So we're going to be working with this haiku.txt. And if we can print a file to the screen using the cat command. So we just type cat haiku.txt. And we can see the poem here on our screen. So the first thing we can do is we could use grep to grab a line of this poem. Let's say, for example, we want to grab the lines containing the word not. To do that, we can type grep. Then we type what we want grep to match. So we want lines that match the word not. And then we give it the name of the file, so haiku.txt. And we can see that there are 3 lines that it prints out for us that match, that have the word not in it. And so it will give us those words in return. Yeah, please. Yeah, so there's the Etherpad URL right behind you. So if you go to that website, I forgot to include this with the data. So if you go to that website, you can, at the very bottom, there's the poem. So just copy that. Oh, you need to set up an internet connection. Oh, that's fine. You could just maybe copy the poem from Chris's. Yes. Yeah, that's a good question. So the question was, does grep only grab lines? And that is the case. Yeah. So grep is not going to grab a column for you. It's going to match. Essentially what it does is you're going to provide it with a pattern. It's going to search your file for that pattern and then return you any lines that match that pattern. If your pattern is distributed between 2 lines, right, there'll be a line break in there that you can't see. So at the end of each of these lines, there's some hidden character. There's a hidden character we can't see. That's a line break. And so that would probably have, I don't think that's going to work. Yeah. So if your pattern is across, if there's a line break. Pardon?
If there is no way to work it out, like ignore
I'm not sure. That's, yeah, maybe throw that question in the Etherpad and we can talk about it later. Are you thinking about sequence data? Yeah. Like in a FASTA file like that? Yeah, so if those sequences don't have, yeah, I'm not sure about that.
Okay.
Yeah, that's a good question. Okay, so let's try a different pattern. So we'll try grep, and let's try to grab lines that match the pattern day from haiku.txt. And what do we see? We have a line that says, yesterday it worked, and today it is not working. And so what we can see is that, yeah, it matches our pattern, but our pattern is contained within another word. And that's okay, but maybe that's not what you want in all the cases. Maybe sometimes you do want an isolated word. And there are a bunch of options that we can use with grep that would let us be able to do that. So in this case, if we type grep and we use the -w option or -w flag, and we type day from haiku.txt, we don't get anything returned because there's, in that poem, there's no single word of day. Okay. So how do you know what all these flags are? So there's good documentation for grep. So how you would access that documentation is on a terminal in Mac or Linux, you would type man grep. And then you'll have a page come up that will explain what grep does. It might have some information for you there about looking for patterns that cross lines. And then it also, as you scroll down, it tells you about each of the different flags and what they do. So that was man grep. To get out of here, you have to type Q. If you're on a Windows machine, it's going to be grep -- help if you're running git bash, and that will bring you to your help page. So that's how you can look at what these flags are. Is there any questions right now? We're all good? Okay. So another thing you might be interested, especially if you're working with a large data file, is if you want to know what row numbers or what line numbers are matching your text or your pattern search. So we can, again, grep has another flag for that. So it's the -n flag. and say we were interested in it. So words or lines that contain the word it from haiku.txt. When we do that, you can see that it has now added little line numbers to the beginning of each line, so that if you had a really big text file, this could be potentially really useful for you. And you can see that I added quotes here. So you can add quotes or not use quotes, but if you start to look for patterns like is not, like 2 words, you're going to want to start to use quotes. And I just want to say the next one, that's numbers. And okay. So we can also, so we can look for case sensitivity. We can tell it to use case sensitivity or to not use case sensitivity. So for example, if we want to do, let's just take a look at the poem again. So cat haiku.txt. We can see that the word the is capitalized as well as not capitalized. So if we just type grep the haiku.txt, then you can see that we only get these 2 lines. We don't get the line, the tau that is seen. So if we wanted to access both of those, we'd have to use yet another flag. So the -I flag is for case insensitivity. So we would type grep -I the, and then the name of the file. And now you can see that we include the capitalized the as well. So I'm just using this silly little poem just so that, because it's really easy for us to look at the whole thing and see what our searches are doing. In a minute, we're going to move to a much bigger data file. And then the last thing that you can do that I'm going to show you is sometimes it's really useful to select things that don't, you want everything that doesn't match something. So what if we want all the lines that didn't use the word the? So there's one flag for that. So we can type grep and then -v. And we also will keep the case insensitivity there and work on the word the. And then the name of the file, haiku.txt. And none of these lines should have the word the in it. So that seems to be the case. So that's a basic rundown of how grep works very simply. So I have a short multiple choice question for you guys. So if we go to the Etherpad, so the URL is right here, as well as on the whiteboard, and we scroll down to this multiple choice question. So using the same poem that we've just been working with, which command below would result in this line being outputted? So feel free to try and play around with it. And in a minute, I'll just ask you to hold up 1 finger, 2 fingers, or 3 fingers so I can take a probe to see where you guys are at.
Then the screen will be less busy.
Remove this?
Yeah.
Okay, how do I do that?
I remember there was a command. I have to say.
Okay, if you figure out the command, I'm happy to do that.
Yeah.
It's the PS1. So if you want to maybe just write PS capital P capital S capital 1 equals no space. Open this for the quotations and just write a $sign. Yeah. Enter. There you go.
Okay. Thanks, Bruno. Okay, so I'm just going to take a probe. If you guys can vote. So put 1 finger up for number 1, grep of haiku.txt, 1 finger up for number 2, grep-e of haiku.txt, and 3 fingers up for grep-w of haiku.txt. So let's vote. Perfect. I see most people voting for number 3, grep-w of haiku.txt. So we'll just make sure that that works. Grep-w, and we were searching for of. That's the right. And that's exactly what we get. So again, the -w flag, what the trick was for that question is it just grabs the word of, not when of is contained in within another word. So there was, in the multiple choice question there was another flag that was in there, and that's the -e flag. And that's to tell grep that you want to use regular expressions. So for those of you who were here last week, Bruno gave us a really awesome introduction into using regular expressions with regexpal. So we can also use those regular expressions with grep. So I'll just give you a brief example of that. We'll use it a little, probably almost not at all today, but you can combine these two tools together. So if we want to do that, we can type grep, and then we type the -e flag to say we're going to use regular expressions. And when you're using regular expressions, I think you need to use the quotes. And the first thing we're going to do is we're going to say we want to match the beginning of the line. Then we're going to use this. Does anyone remember what this matched from last week? Any character. Yep. So first, this means first line, any character. And then the second character would have to be an O. So this is the pattern that we're going to match. So we want to grab any line that has the second character being an O from our poem, haiku.txt. And then you can see that it grabs 3 lines, and just as we asked for, the second character for each line is an O. So we can this could start to become really powerful depending on what you're doing. Okay. So any questions on very basics of grep before we go on to looking at a bigger file? Going once, going twice. All right. So I am just going to make this small and just show you what the data looks like, that basically the directory looks like that what I have given to you. So we have a genomic directory and a behavior directory. So my research has to do with looking at genome sequences of C. elegans and nematode worm, and then I also use automated behavioral analysis with them. So I decided to bring 2 of the data that I usually interact with just to show you they're kind of biggish types of files. So how we might use tools that I commonly use in the shell to work with this stuff. So we're going to be working in the genomic folder, and we're going to be working with what's called a variant call file. And so I'll just open this briefly in Text Wrangler. It's a bit of an ugly file, I'll warn you. Not that one. Here we go. So these files sometimes have a really long, ugly header that is preceded by 2 comments or hashtags. Then we have a more useful header that is basically lines up with each of the columns in the file underneath. So you can see that immediately loading this into, although sometimes they're quite big, you wouldn't want to load them into Excel, even just loading them into R like this without some special tools, it's not your regular rectangular data set. So this is what we're going to be doing. So we'll be extracting some rows from here, as well as learning how we can extract some columns from here too. So I'll just keep this small so we can go peek at it later. So the first thing that we want to do is looking at this variant. Okay, yeah. So the first thing that I want to do, I don't know how I did that, is looking at this variant call file. I want to basically remake this. I want to keep this variant call file, but I want to do in the same format that it is in, but I only want to have chromosome 3, for example. Okay, so I just want to look at all of the mutations on chromosome 3. I don't care about chromosome 1 through 6. So how might I do that? So, I mean, there are tools built in other languages to do this, but you can do this easily in the shell. So if we go back to the terminal, which I wonder if I have closed. No, it's here. Perfect. So first we need to navigate. Let's first navigate to the directory where this file is. So we want to change directory into data. And then we can look around and we can see that those two folders exist that I showed you, behavior and genomic, with the ls command. So then we can change directory into the genomic directory. And then when we type print working directory, you should see that the last thing is genomic. And if you type the list command, hopefully you see this VCF file. So give me a yellow sticky if you're with me in the same directory before we get going. Great. Okay, mostly everybody's there. Fantastic. All right. So the first thing that I'm going to do is I'm going to use grep with regular expressions to grab all of that ugly header and put it in another file. Okay, so to do that, I would type grep. And what was the flag for regular expressions? Does anyone remember?
Capital E.
Perfect, capital E. And then I'm going to give it my pattern. So I'm putting that in quotes. I'm using this up arrow to basically tag it to the front of the line. And I'm going to grab everything that starts with a pound symbol. And I'm going to be taking that from mmp.vcf. And I will be using this caret to make a new file that I'm going to call chromosome3.vcf. I'm going to hit enter. And then the next thing I'm going to do is I'm going to use grep again. And I'm going to use the -e flag again for regular expressions. And this time my regular expression is just going to be simply, I'm going to tag it to the front of the line, remember, because my chromosomes are my first column. And I'm going to grab the third chromosome, and I'm going to, again, grab it from the mmp.vcf file. And this time, I'm going to append it to the bottom of that file that we just created, chromosome3.vcf. We hit enter. And then it's kind of difficult to peek at. I don't want to cat this whole file to my terminal because it'll be a bit big. So we're going to just use head and tail just to take a little peek at if we think what happened. So I'll just type head, and I'm just going to look at the first 5 lines of this VCF file. And we can see that it looks like I have grabbed those ugly looking headers. And then if I peek at the tail, I should hopefully see a couple rows where it looks like that at least starts with chromosome 3. So I'll look at the last 5 lines there. Maybe I'll just look at the last 3 lines there of chromosome 3.vcf. And I can see there's one row with chromosome 3, there's another row, and there's another row. I'm going to actually peek in my text editor just because it's a little bit easier for me to look at that. So I'll just open this here, which is down here. Oops. And I can see that my chromosome 3.vcf has all the header information. And then lo and behold, if you look at column 1, you can see that it has all the chromosome 3 data that I'm interested in. Okay, so my challenge for you guys now is to do this, but try and do it for chromosome 1 instead of chromosome 3. I'll type the question into the Etherpad. So essentially just make a VCF file that's going to have the header as well as all of the variants for chromosome 1. Oh, it doesn't like that. And feel free to chat with each other. You don't have to work alone. And maybe yellow stickies down and then put your stickies up once you've solved that.
So like, be careful with that because you can do it with an 800 that you write it. These are 6 separate columns.
These are space, yeah, they're space separated. Column, I think column number 8 is a mishmash that can be also separated, but it's space separated. So yeah.
Do you want to show them the man command too, just so they
Oh,
know how to look
I did, but I can show them again. Yeah, just a reminder, if you need some help to figure out if there might be, I'll give you a hint, you need another flag that we've already talked about. So to get to the documentation, it's man grep on a PC or on a Mac, sorry, or grep -- help for a PC.
So what you've prepped for here is everything that's starting with I. That includes I, and I, and I, and IB, right?
I have no idea. So I have to see that. Oh, she just wants everything from chromosome 1. One is I, also Chris is what does the name do?
Could you run the same PS1 command but add a space after that?
Yeah.
Makes it a bit more readable.
I'll also clear my screen. Would I have to do this every time I start up a terminal, or does it save it like that?
You would have to do it every time, or you add it to your bash profile,
Okay.
which is what I do at C. And there's a lot more you can do with this. You can add your home directory. What I have is I have the first line being a directory and the second line being the $sign. So
Oh, that's
no matter
nice.
what, my commands are always to the left, but I
Yeah.
have the extra information there every single
Oh, that's
time.
nice.
There's tons of I could probably color use my PS1.
Oh,
You could probably use my PS1 in the Etherpad.
that's handy. Yeah.
There's actually a ribbon type of.
Okay.
And also add current branch you're on.
Oh, that's cool.
So, yeah.
That's really cool. All right. So it looks like we were at half the people there. I'll give you another minute or two, and then okay, we got more than half the people there. All right, so let's take it up. So maybe I will get everyone to paste right here after challenge 1 on the Etherpad. Can you just throw your answers into how you did it on the Etherpad?
Yeah, but they're in different territories.
Okay, so that's good. That's an interesting one. So here are using regular expressions to grab the header, just like we did for chromosome 3. But if you just use the same, if you just use I, it's going to also grab chromosome 2 as well as chromosome 3, but you just want to grab chromosome 1. So you know that there's a space delimiter after the I. So that's a good way to do it. Did anyone do it differently than this, or is this how everyone solved it?
I did W.
Okay, great. Do you want to paste your answer in then, Chris? Or are you having trouble?
I can't copy and paste.
Okay. I'll just
You can shift control.
So you would have done the same first line, right?
Shift control C.
if you're having trouble, so like Control C is like kill with map, but Shift Control C will copy.
Okay. So Chris, maybe you can just dictate to me what you wrote your second line as. I'll type it in the Etherpad here. So,
Dash capital E.
Yeah.
Dash W.
Yeah.
And then quotation mark.
Yeah.
Caret I.
Okay. Just like that? Perfect. Awesome. So as per usual, there's a couple different ways to skin a cat, and both of these solutions do seem to work. So that's great. So awesome work, everyone.
You can also one-line the first solution by putting it into like an or using a type character, so you can do.
Oh, okay. Yeah, let's do that. Did you paste yours in the Etherpad or?
Not yet.
Okay, paste that in the Etherpad and let's chat about that. That's a good one. Because we are going to talk about pipes. Or you're not piping. You're using it as an or. Okay.
I don't know if it's worth discussing. That's just sort of like the smart ass version.
No, it's fun. Just paste it in there. It's always good to see different ways to solve things. Or if you want to dictate, if it's easier for me to do that.
Yeah, it's just.
So you did grep.
Grep dash E.
Yeah.
And then in quotes.
Yep.
Caret. Open bracket.
Open bracket. Okay.
Hash.
Hash.
Pipe. I. Or,
No,
space. Yeah.
Yep.
That's
I.
Space.
Space.
Close bracket.
Close bracket. Quote.
Yeah.
Okay. So.
The space works there because we're in parentheses, not close braces. So we've got.
Okay. So that's a one-line solution. So I don't know if you remember from last week, Bruno taught us that this straight up and down in regular expressions is or. So here it's saying grep anything where the line starts with the hash or anything where it starts with an I and a space. Awesome. Great. Okay, so this is awesome. So we are very comfortable now manipulating this file using grep. But what if, for example, you wanted to know, I think, let's try to take a, yeah. I just wanted to know what are all the variants in this file? I just want to grab that information because I want to use it for something else. So just for non-genomicists, the third column here are allele names or variant names. So how would I just grab all of the variant names from this column? Pardon? They all start with GK, yeah, but you might have some GKs over here buried in stuff, so that's something to think about. So we're going to learn to use a different tool. We're going to combine grep and awk to do this, to solve this problem. So the first thing we're going to do is we're going to make a rectangular data set because awk is much happier with a rectangular data set to get rid of the header. So we're just going to make a temporary intermediate file that we're going to work with grep. So we're going to go grep -e, and we're going to use the -v flag, and we're going to grab everything that does it where the lines don't start with the two pound symbols. And I picked the 2 pound symbols because I want to keep the header there for the first line, which actually is the header for the columns. And we're taking this from mmp.vcf, and we're going to make a new file that we call mmp minimum header.txt, because it's not really a VCF file anymore. So we'll do that. We create that new file. And if I just type head -1, or I'll do -2 to make you to peek at this file, we can see that it's changed. mmp min header.txt, and we can see that we have this first line, which is the headers for that file. We no longer have that big, long, messy header, and this is what our first row looks like from that file. So now we have a file that's rectangular, and we can start to use awk on it to extract columns. So just like any other tool, we start off with the name of the tool. So the name of the tool is awk, but then everything you give awk, you have to put in quotes, and it has to be in single quotes, not double quotes. Otherwise, it won't work. So it's single quotes, curly braces, print, $, and then the column number. I want to print column number 3. And then the name of the file, mmp min header.txt, and I'm going to save this to a new file called mmp variance.txt. Okay, so we print enter or press enter, and then we can just use the head command again to peek at this new file that we've made. So let's just look at the first 3 rows of it, or I guess the first 5 rows of it, of mmp variance. So head 5 mmp variance.txt, and you can see that I've got the header, as well as I have a list of all the variants. So awk is very useful for grabbing specific columns. You can't do that with grep, but you can certainly do that with awk. The next thing is we're going to be playing with awk a little bit. I don't want to create new temporary files just to make sure my awk commands are working all the time. So we're just going to pipe to head. And so for those of you who haven't heard of a pipe before, we use the same symbol in regular expressions. It's that up and down arrow, and it acts like a literal pipe. It takes the output from one command and sends it to the next one. So to do what we just did, we would just type again awk print the 3rd column of mmp min header.txt, and instead of saving it as a file, we're just going to use that pipe and pass it over to head -5. Okay, so everything from here is not going to be saved as a text file. It's just going to go be directly fed to head, and we'll get to see what the first 5 lines are, and you can see that they're the same. So it's a nice little tool to just check things before you want to save things to a file. Okay. So the next so I'm just going to throw a little challenge at you guys. I want you to look at this. I want you to, from this mmp min header file that we've made, I want you to grab the info column. So just extract the info column. I'll write that into the Etherpad. And take your yellow stickies down until you're done, and then put them up when you're done. Okay. Looking like everyone is there. So does somebody want to just tell me their answer out loud, and we'll see if it works? Anybody? Remy. Anybody else other than Remy who wasn't listening want to tell me their answer?
It's just the same except for 8. I think.
Exactly. So very simple. We're going to do awk, use the funny syntax with the single quotes and the curly braces. Info is the 8th column, and we pass it the file name. And we'll do the same thing by piping it to head just to check that it's what we want. And we can see that we get that big, ugly middle column of the VCF file. Okay, this is great. You guys are very comfortable dealing with this. So we also get the header. What if you don't want the header? So there is some syntax in awk that we can use to not have the header. So to do that, so we'll go back to grabbing the third column, the allele column. So we can just say awk, and then we use an if statement. So you go if, and then in brackets, NR, I'll explain this in a second, greater than 51, print $3, close the braces. Okay, so let's just take this one line and break it down. So the only thing that's new to this statement from the one that we previously did is the if NR is greater than 51. So essentially it's saying if the number of rows are greater than 51, print that column. And why I picked 51 is, I forgot to mention this at the beginning, then you can use this and apply this to the original VCF file. Because I can skip all those headers. I don't actually have to make an intermediate temporary file. If I know how many of those header rows there are, I can skip all those header rows and then use awk to interact with it as a rectangular data set, which is kind of cool, I think. So then we can just use mmp.vcf, and we can pipe that to head, -5, and we should see that we get, I kind of combined two things here, sorry. We get the column that we want without the header, and we were able to do this on the original file. Does anyone have any questions? Or I threw 2 bits of information at you there. Are we all good? Okay. And then the last thing that I'm going to show you with awk is, there's 2 other things I'm going to show you with awk. So what if we wanted to grab multiple columns? So you can just keep specifying the column number with putting basically $1, comma, $2, comma, $3. So like if we want to grab the first 3 columns, I'm just going to clear this. We would just type awk, funny syntax, print, then $1, $2, $3. Oops, I forgot my, I'm going to work on the original file. So my if the number of rows is greater than 51. Then we're going to print the first 3 columns out from the original VCF file we've been working with. And I'm going to pipe that to head just to peek at it. And we can see that we get, this is column 1, this is column 2, this is column 3. We don't get the header, and we get 3 columns. Now, what if you have 15 columns you want to grab? That's kind of annoying to keep typing this out. So I'll show you the syntax for it. It's not, it looks very complicated. And awk, essentially, it's its own programming language. And we're just using little bits and tricks of it here, but we could spend many study groups on awk. And if people are interested, we can bring, I'm not an awk expert, but maybe one of you are, or we could find an awk expert to come in and teach us. Because as you can see, it can be very useful. So how do we get, let's say, for example, seven columns without typing them all out? So we start off with awk again. And oops, we need our quotes and curly braces. And then essentially you have to use a for loop to do this. So you type for x equals where you want to start. I'm going to start at column 1. And then we're going to go to column 7. And each time we're going to add to x that we go through this loop. And then instead of using the print function, we're going to use the printf function. And we have to tell it now that we're going to be dealing with strings. And we're feeding it x, that's what it's going to print. And then it's going to print, I think, a new line. I'm not an expert at awk syntax, but I can tell you that this solves the problem. And sometimes that's good enough. Okay, and then I think this should do it. And then pass it the file. And I will pipe that to head. So you can see that it's quite long syntax. So unless you're doing, maybe even for 7 columns, it's not worth it. But maybe if you're doing 20 columns, it would be worth it. Yeah?
I think you're missing a less than or equal in the photo.
I'm missing a less than or equal. Oh, yeah. Thank you. I am at the 7. Good eye. Here, -5. And is that what I wanted? Nope. What did I do wrong there?
Did you do?
Oh, I didn't do the note and row. Okay, so I'm actually, yeah, my plan was not to apply it to the original VCF file because I couldn't figure out how to do that. So I was going to apply that to the min header file.
Or you can use grep and pipe.
I could use grep and then pipe. Yeah. Yeah, let's do that. Okay. Let's go back. So where did I type that in again? Okay, I'm going to start from the beginning. Oh, here we go. mmp.vcf head -5.
Code works here.
Pardon?
This single code.
Oh, what is this? The single quotes? So the single quotes surrounds the syntax you're feeding to awk. So like everything within the single quotes and the curly braces is an awk program, right?
Yeah. So
Or
I
an awk
think-
script?
Yeah, I looked into this. It's funny because single quotes and double quotes don't exactly mean the same thing in Bash. I think my
It
understanding
depends on the program.
No, but I think this is if single quotes, things inside the quotes won't be interpreted by Bash, while double quotes will be. So here, maybe
I'm just gonna type
the
this in.
$1 won't be interpreted as a Bash variable in single quotes, but double quotes it will.
Okay.
So just in awk, you always use single quotes.
Okay. So let's do it. Bruno suggested, and so we'll use grep to pass everything that's not the header to awk, and then we can just print out those range of columns. So we're going to use the regular expression flag as well as the not matching flag, and we want everything but the header, mmp.vcf, and we are going to pipe that then to awk. And we write our for loop. Where are my quotes? And yeah, you'd really want to be doing a lot of columns if you're doing this, as it stops being less efficient than maybe using some other tool. Oops. And then we'll pipe that to head -5. And hopefully this works. Yay! Okay, that does exactly what we wanted it to do. But you can see that this is, it took a lot of typing.
Do you want to explain a bit what is?
Yeah, I will. So, okay, so this line of code gave us that range of columns. So the first thing we did is what Bruno suggested, so that we can work with the original VCF file, as that we grep everything that doesn't include the header, right? Remember, it has that big ugly header. So we say we want everything that doesn't start with the £2 symbol, so we can grab everything beneath that. Then we use the pipe, and we're going to send that information to awk. So inside awk, we have a for loop that is going to be going through the different columns. And for each column, it will be printing the column. And then we pipe that to head so that we can peek at it. Or we could send that to a file, for example, if we wanted to grab that.
I mean, like, what is print as opposed to print F?
So there are two different functions in awk. And to be honest, this is kind of my extent of awk, is like just knowing how to do two little tips and tricks. But as I said, if people are really interested in learning more, we should totally get, does anyone else use awk more often? Do you know the answer, Bruno? Print versus printf? I don't know a lot. Like, they're different functions, but I don't know what the
Yeah.
extent of what they can do are.
I'm not familiar with it.
Yeah.
I think F stands for format line.
Yeah,
I mean, what is in quote is format line.
A format line. Okay.
yeah, so I don't think you could do that, you know how you're telling it to format as a string?
Yes.
First thing,
Okay,
you couldn't do that with just print, it would just.
It doesn't have that option. Yeah.
So you're just trying to get the first 7 columns.
Yeah. Just grab the first, or sorry, say that again.
You're You're trying to just take
Just the first 7 columns, or we could grab the first, or you can go from a different range. So like you could just basically take this, if you wanted to grab like the 20 to the 29th column, you could just replace this with 20 to 29 in your for loop, and it will, and you would be able to grab those things. All right, so those are little tips and tricks in awk. The last thing I'm going to show you is how to use find. And I'm just going to show you 1 or 2 tricks in find because we're getting really short on time. But does anyone have any other questions that maybe I can try and answer about awk or grep? I'm sorry I can't answer everything, but.
So this thing in quotation marks here is a thing.
This?
That, yeah. So that's a thing that awk then runs for every line in the file.
You can imagine it as being a program, like an actual program that fits on one line.
Yeah.
Yeah, and yeah, awk deals with like each line as being a separate thing, and it runs on that sequentially. Yeah. But there's ways of doing code at the beginning and at the end. So for instance, let's say you have to specify what separates each column. There's a way of doing that, and you want to run that at the beginning. There's a way of doing that.
Yeah, and awk programs can get quite large. So you could write a large, like a 30 or 100 line awk script, and then pass the name of the script in here, as opposed to just doing a one-liner. But I just wanted to show you guys this because it's kind of the next obvious thing. If I can grab multiple columns, how do I grab a range of columns if I have a lot of columns to grab? So, yeah. Okay, so the last thing is find. So I'm just going to show you briefly what we want to do with find. I'm not going to have time to do it justice and explain everything. But if I take you back to my finder, we're going to look at the behavior data I have here. So one thing that I have to do, so just to give you a little rundown, each of these directories are output from an automated behavior experiment. So a computer vision system has analyzed hundreds of worm behavior and given me that information as text files. So this was one plate of 100 or 200 worms. This was another plate of 100 or 200 worms. So in each of these, I get a DAP file for each worm. They all have the same columns, so I would just like to combine all these data sets. Maybe that's not the optimal way for whoever wrote this software to give me my data set, but this is what I have to work with. So I need to, because I want to put all these data sets together in R, for example, or in Python, I need to combine all of these DAT files in this directory together, plus with the other ones in the other directories. And happily, there seems to be other types of files in there that I don't want to combine. So how can I quickly and easily make a big data set with all these disparate files? It might be something that you might come across in your research. So that's what I'm going to show you how to do next. So heading back to the shell, we're going to navigate now to the behavior directory. So where are we again? Print working directory. So we need to move back up to the data directory. So we do that with cd ... So ... means parent directory. So we go up and I'll type print working directory. I can see that I'm in the data directory. And then I type cd behavior to get to the behavior directory. And when I print working directory, I should see that I'm there. So that's where we're all going. Just give me a yellow sticky just so I know I don't want to get started before everyone's there. Everyone should be there. Okay, great. So just so that you can clearly see it, I'm going to show you how to use find with the summary files because I only have 3 files so that you can visualize it, and then we can do it with the big data set. So find is interesting in that it works. It can work recursively. So you can be, if you're in a directory up here and you have other directories beneath you, it will look in each of those subdirectories. You can limit that with different flags. Again, you can use man find or find ... help to get more information about that. But it's not, it doesn't just have to look in your current directory. It can look in directories beneath that. And we're going to take advantage of that with the find command by sitting in the behavior directory, and we have 3 other experimental directories underneath of us. So to get the names, for example, of all of the files that end in .summary in my experimental folders, I would type find ... which means current directory. So start looking in the current directory. And we're going to use the -name option. You can also, like I said, there's many different types of options that we can give to find, and you can look up those up in the documentation. And then I want it to find things that end in summary. So just for those of you who haven't seen this before, this is a wildcard, and it matches any character. So it's going to match any file that has a whole bunch of characters in front of it that ends in .summary. And when I hit enter, it's going to give me the name of those 3 summary folders.
So can you tell me again what does dot do at the time?
Yeah, so that's the current directory. So you need to tell find where to work. It doesn't assume you want it to do anything. You have to be explicit about where you want it to look. You could point it somewhere else from where you are, and sometimes that's extremely useful. So now that's great. Now I can have the names and the paths from where I am of these files, and now I could use something like the cat command to put those all together into one file. So we've been using pipes a lot, so you imagine maybe you could do something like I find dot dash name of summary, and then I pipe those to cat, and then, or sorry, I don't send them. I pipe those to cat, and then I output that to a file. So let's just call this all summaries.summary. So let's take a look at what all summaries.summary, because that seems reasonable, right? We'll take a look at what all summaries.summaries looks like. And unfortunately, all we got were the names of those files. So although pipes is very useful for putting together certain commands in the shell, there's another way that you can use, that you have to use to combine finds output with things like cat and grep and potentially awk. So how we do that is kind of similar to math with bedmass. So you start with cat, or the other command that you want to combine it with, and then you create a set of brackets. And inside those brackets, you're going to tell the shell, do this first. And then the other command will be able to be applied to that. Okay? So does that make sense to everybody? Okay, so here is where we would put our find command. So the same one we've been using. Find dot for current directory. Going to use the dash name because we're searching via name. And then we're looking for anything that ends in summary. And we are going to save that. We're going to overwrite the file we previously made, all summaries.summary. And that's going to take a little while, maybe. Or I made an error.
Also need a $sign.
I also need a $sign. I have a $sign here. But it's chugging along very slowly, which usually means I made an error. Okay, let's break this. So if you get stuck with me, hit Control-C, and you should be able to break out of that. Okay, so I'm going to try just with the more obvious one. So this is another command called word count. So it's going to tell me, and if I use the -al flag, the number of lines. So I'm just going to try and figure out what mistake I was making. And so $sign, find.
Do you have to delete the all summaries.summary?
I shouldn't have to. If you use 1 caret, it should just overwrite it.
But like, will it find the all summaries.summaries and then kind of go recursive?
Maybe. Oh, that might be it. Okay, let's do that. I like that idea. I like that theory. So to delete a file, we use the remove command. So let's remove all summaries.summary. And let's try that cat command I did before again. So combining cat and find. And I am, yeah, let's send that to all summaries.summaries.
You add change it to .txt maybe.
Change it to .txt. Oh, that's a good idea.
Command and creates the file, so they know.
There you go. Let's do that. Ah, that was way faster. And that probably worked.
It worked with me, but it's typed in summary as well.
Oh, okay. Well, we can try that. I'll just That worked too. Okay. But it was because it existed before. That's the problem. Thank you. So now we can peek at all summaries. I'll just head that file. So let's just take a peek at the first 5 lines of all summaries.summary to see if it looks like there's data in there. We can see that there's a bunch of data in there. And then we can use that word count -L to do some sort of a sanity check to see if there's a bunch of, there's more, we should have done that at the beginning to see how many lines were in the individual files. And then you combine them and then make sure that those numbers add up to your combined numbers. So this would be word count of all summaries dot, summary. And it's 44,000 lines.
You can do the same with star dot summary and just word counts all that goes with dot summary.
Oh yeah, okay. I didn't think about that. That's fantastic.
I know, but they're in subdirectories.
Yes, so we would have to find them. We could do that though. We could go word count -L, find, we need the $sign there. $sign, find current directory, names of everything that's going to end in .summary. And that should work, I think. Nope. Quotation. Right, I'll break out of that. There. There we go. That seems to make somewhat of sense. So that's how you can do your sanity check to make sure it worked. So yeah, so there's very rapid explanation of 3 tools I find really useful. Does anyone have any questions before we wrap up? We're good? Okay, awesome. So again, next week we're going to have a co-working session. So come bring your projects. We can all help each other. I'm really looking forward to it. And then on the 21st, on the Friday, we're going to do a hacky hour at Clubilia. Just hang out, chat about what we like about computers, what we don't like about computers, get to know each other better. It'll be fun. All right, that's it.
Another question I have for you, just to get a feel in the room. So for your schedules in fall, when will you know, are many of you waiting for TA ships? When are you getting the results for those? Soon, I imagine?
Just show this too.
Like for most of you, are your schedules settled for next semester? Because I'm going to be sending out Doodle poll for everyone, just so we can figure out what's the best time during the week that fits everyone's availability. So I just want to know, is everyone ready, or should I just wait a bit more until the TA shifts are announced? Most people are already settled with their schedules.
I'm settled.
Okay, so
I'll just throw data point out there.
Yellow stickies if you're settled.
that's the way to do it. And speaking of yellow stickies, please, can you write on the red sticky one thing you would like to see improve in this workshop, and on the yellow sticky one thing that you enjoyed from the workshop, and on your way out, just stick it on the wall so that we get that feedback over time.